Hello! You will not believe the difficulty level of the problems that you're going to be doing today. You're going to be so proud of yourself. So this is 3.5. This is where we're going to combine the two different one-step equations into two-step equation solving. And we're also going to learn how to do the regular three-line formal check, but because we've got extra work, it may turn into a four-line check, just so that we can show all of our thoughts. This isn't something you're going to need forever, but this is definitely strong foundational support. We want to make sure that you know what you need. So the assignment, you always write your name and period in the upper right-hand corner. The assignment is 3.5, page 112 to 113, numbers 1 to 37, odd only, and that means you're going to self-check. That also means that you're going to recorrect right away if you have something wrong and learn from your mistakes. Now, I've already started this video once. I learned from my mistakes. It's hard to keep the DocCam and all of the fraction work and decimal work nice and pretty for you, so I'm trying to do it nice and neat. And you can always stop the video if you need some extra time. Students that choose to watch the video over the weekend, then you can have this for yourself, and that way you can buy a little bit more time if you needed to retest today, because this is the last day of the first quarter. Okay, number one, the question is, how do you solve two-step equations? Now the book talks about how you will eliminate the constant, and then you would either undo multiplication or division. We've talked about it with an analogy of a cake. So we've been doing addition and subtraction problems that you undo, and then multiplication and division problems that you undo. If you look at your ISF notes, you're looking at page 46 and 47. But today it's time to combine them together. So to solve two-step equations, you would undo addition or subtraction first, then undo multiplication or division. Now we're going to jump down to number 7, and you may not believe that you can do this type of problem, but you totally can. 4b plus 3 equals negative 9. You can't just look at it and figure out what b is. It would take some doing, but you can show the steps and make sure that you're solid and that you understand how to do this type of problem and even more difficult problems. So the 4 steps that you have from your ISF are: you draw a line down, separating the problem into two different sides on the equal line, on the equal sign. Then you're going to undo any addition or subtraction first. Since they were adding 3, you're going to subtract 3 on both sides. Next, just look at the equation part right now. We'll get to the check in a minute. Because you have negative 9 and negative 3, those signs are both negative, so those are both negative terms. So you're going to use the rule same, add, keep. 9 plus 3 is 12, and you're going to bring down the negative sign with a sign trail. Hopefully you know that negative 9 and negative 3 combined makes negative 12. On the first side, though, you're left with just 4b. So you bring down the 4b, and you're done with the first step. You undid addition and subtraction. But now they're multiplying b by 4. So the opposite of multiplying by 4 is going to be dividing by 4 on both sides. 12 divided by 4 is 3. When you multiply or divide, one negative means the answer is going to be negative. b equals negative 3. Now it's time to do the check. The first line of the check is the question, so you know that you've got 4b plus 3 equals negative 9. Then the second line of the check, you take the negative 3, substitute it in right where the b was, and you put a little question mark on top. The baby question mark is to remind us that we haven't checked it yet, and we don't want to just put equal when we're not sure. So we're going to put the small question mark right here just to make sure that we know that this has not been verified yet. Now it's time to do the math. 4 times negative 3 is negative 12. Plus 3. Does that equal negative 9? Well, we're still not sure, so we're going to put another line here with a small question mark. The baby question mark is cute, and it reminds us that we're trying to check our work. Next, negative 12 plus 3. These signs are different, so you're going to use different, subtract bigger. 12 minus 3 is 9. The team that has the most players is the negative team this time, so the greater absolute value is the 12. The sign is negative, you bring it down. Negative 9 equals negative 9, check. You'll notice all this side is negative 9, And then on the last, it's the reflexive property, -9 equals -9. Check. Okay, now we're jumping to problem 17. I'm thinking it's pretty difficult. It's got a lot going on. Okay, first, let's cover up the check so that you don't get distracted. Okay, so the question, line by line, the question is 7.3y minus 5.18 equals -51.9. So if we were trying to make this into like a real life problem, maybe you wanted to buy yo-yos and they cost $7.30. So that would be 7.3. Now you already had to pay $5.18 for something, so that's negative money that you owed. And you're trying to use up, or you have negative 51.9. That's like you owe $51.90. Okay, so we got a lot of different money connections here, and we'll just think about that loosely. We're going to follow our procedure, starting with putting the line straight down the equal sign. Next, you're going to undo any addition or subtraction. Since they were subtracting 5.18, we're going to add 5.18. When you add, you've got different signs, so the rule that you're going to use is different, subtract bigger right here. 51.9 minus 5.18, you're going to fill in with a 0. Just line up the decimals, you can add them with ease, or fill in with zeros and subtract if you please. Remember, the rule is telling us that we're going to subtract. Other people might be getting confused at this time because it's got a plus sign down here, but you're going to subtract the two numbers. So you're subtracting, and you're going to end up with negative 46.72. On this side, you still have 7.3y, bring that down. These two are a zero pair, they cancel each other out, so they just disappear. They're just gone like that. So now you have 7.3y equals negative 46.72. Okay, this means that you're going to multiply, so the opposite is divide. So you're going to divide by 7.3 on both sides. Now, I know that you think, oh, Miss Pierce is not going to do the math. Yep, I did the math. Right over here, we've got 7.3 into 46.72. This is, or if there are two, move them both, then straight up divide. So you see the two decimal points? This is going to move over one time to make it a whole number. So this one also moves one time to make it a whole number, and then straight up. We're going to think of 7.3, which is now 73, like 70. So we have a cloud above there just showing 70. So now if you're thinking, okay, if I cover up the 0 of the 70, it turns into a 7. And if I cover up the 7 here, it's like 7 into 46. Well, 7 into 46, thinking of the 7 times tables, is going to go 6 times. So that's the number that I'm going to try. But I switched to pencil in case I made a boo-boo. But I was right. 6 times 3 is 18. Put the 8 down. Carry the 1. 6 times 7 is 42. Plus 1 more is 43. When you subtract these, you get 29. 29 is less than 73, so that's the good sister step. Just checking for dad, mom, sister, brother, if you want to use that for the long division, because it's still a lot of steps with any long division problem. Now it's time for brother to bring down the 2. So your new question is 73 into 292. But it's easier if you say 7 into 29. So 7 times tables, you've got 7 times 4 is 28, so that's the one that we're going to try. Put a 4 here. Oh, it looks pretty good. 4 times 3 is 12, and then 4 times 7 is 28, plus the one that we brought over is 29, and it's a terminating decimal. Terminating, nothing left. So you've got 6.4 as your answer. But is it really? Let's go back to the question. Y equals 6.4 looks pretty good, but if we look at the question, we're dividing a negative by a positive, so it's going to be negative 6.4. Whew, a lot of work. But step by step, it's still the same exact problems that you've been doing, same building on what you already knew. Okay, now it's time for the check. The check starts with the question itself. Switch this over a little bit. Then Second line of the check, you're going to substitute negative 6.4 right here where the y was. This means to multiply, so you're going to multiply 7.3 times negative 6.4. When you do that, sorry, that's over here, you get 46.72. I wanted to show it someplace, so we got a little crowded. Negative 46.72, still minus 5.18 equals negative 51.9. But does it really? Are we sure? Well, we're not sure yet. So again, we're going to employ the help of our friend, the baby question mark, until we're sure. We're pretty close. We're going to combine you owing $46.72 and you owing $5.18. They're both negative terms, so we're going to use same add keep. When we add them, we line up the decimals and we get 51.9. There we go. We're going to remember that it's negative because these are negative signs that we're going to keep. So if we wanted to do a sign trail down, we totally could. Negative 51.9 equals negative 51.9. Check. Whew! Didn't know you could do that complicated a problem. Woohoo! And you can pause at any time, copy this, do what you need to do. We're buying ourselves some extra minutes in class. Okay, number 25 is the next one that we're going to do, and I will do this one out with you. It's a fraction problem. So in order to add or subtract with fractions, we've got to have the LCD. So if you need to refresh your memory, the LCD song is also on YouTube. Please check it out. It says, first thing, you got to check if one goes into the other, but 4 won't go into 5, 5 won't go into 8, it just won't work out. 4 goes into 8, but the 5 won't work out. So you have to think of another number, a multiple of 4 and 5 and 8, that they all three will fit into evenly. And that answer is 40. So 40 is the LCD. Change the bottom numbers, make them all the same. LCD. Then you do conversions, add, subtract, okay. So we're going to convert now. In order to make 4 into 40, we multiplied by 10. So we're going to do the same thing with the negative 9. Negative 9 times 10 is negative 90. Still keep the v. That's the variable v. 5 times 8 is 40. So 4 times 8 is 32. 8 times 5 is 40. So 7 times 5 is 35. Now, we're going to draw our line down. We're going to undo addition and subtraction first. So they are adding 32 over 40. So we're going to subtract 32 over 40 on both sides. This is simple. 35 minus 32 leaves us with 3/40. That's nicknamed the frosting. So we have 3/40 and negative 90 over 40 v. Okay, so now we have to get rid of this fraction. Now we had this cute little cheer. If ever you have a fraction in front of the variable, you're going to flip it and multiply on both sides. Again, you flip it and multiply on both sides. Last time you flip it and multiply on both sides. This is the same exact thing as the dividing detour, where you're going to use, instead of dividing, you're going to use multiplying by the reciprocal. And we use the mnemonic to help us remember keep, change, flip. But if it's a fraction, an easy way to remember is you just take this fraction and you multiply by the reciprocal. So it's going to be 40 over negative 90. Now you're ready to do factor bubbles. The 40 and the 40 both easily just turn into 1. And by now you really don't need factor bubbles for this anymore. You know, if they're twins, you're going to divide by whatever that number is, and it's going to become a 1. You've seen that pattern so many times. Should be second nature to you. 3 and 90, both are going to be divided by 3. This becomes negative 30. This becomes 1. So now you have the 40 on the top, the 40 on the bottom, the 90 on the bottom, the 90 on the top, these all factor out and they turn into ones, and that's why we do it, so that you'll just be left with V. Sorry, honey, I will call you back. I'm recording for YouTube. Bye. Sorry. That was Mr. Pierce. And now we've got V equals 1 times 1 is 1, 1 times negative 30 is negative 30. V equals 1 over negative 30. And you know the negative could live on the 30, it could live in front of the 1, or it could live in front of the fraction bar. Any of those three places makes it a negative term. Our line didn't quite go down long enough. There it is. Okay, now it's time to check. First line of the check is the question, negative 9 over 4, V plus 4/5 equals 7/8. Now, everything stays the same. Oh, I'm sorry. Let's change it into the LCD right now. Let's make them all into over 40. So we already knew our conversions. We already saw them over here. So let's go ahead and use those again. So we've got negative 90 over 40 plus 32 over 40 equals 35 over 40. We're not sure if it's equal, so we're going to put the baby question mark. And here, instead of the V, we're going to put in negative 1 over 30. Now, simplifying this, here you can still do factor bubbles. So 30 and 90, you can divide them both by 30. This becomes a 1. And this becomes a negative 3. So now you have negative 3 times negative 1 is going to be positive 3. 40 times 1 is going to be 40. Now we're bringing down the plus 32 over 40. Does that equal 35 over 40? Yes. So now that you're getting to these really, really challenging problems, this is algebra. There's no getting away from it. This is significant and serious work. You can see that 3/40 plus 32/40 is 35/40. 35/40. Check. And you've got to feel good about that. That was a significant problem, so you can't see the check part. And there you go. You can freeze it right there if you need to. Alrighty. This one's a little bit hard to see. The one I probably should have put on the other side just so that you could see it a little better. So I'm going to fix it so that it's not before the negative. There we go. Okay. There's a good shot of the whole problem. All right. So we did 1, 7, 17, and 25. Good samplings for you for all the different types of problems on 3.5. I'm sorry that the book and our tasks are asking us to do so many things all put together, but I am really proud of you for the challenge that you give yourself and the way that you push yourselves to do all the steps that we've learned and put it all together. Show this to your parents. Show them this complicated work that you're doing. Be proud. You're working really hard. And things will get actually a little bit easier after all this rational number work that we're doing in solving multi-step equations. Thanks. Take care.